Guys, we're back. I think I owe everyone here a hyperMILL tool database video. We're going to skip past that. I'm going to start fresh from the beginning. hyperMILL basics all the way through some more advanced stuff. I have a new guy working with me, and I kind of want to put together some videos so that he had a point of reference as he learns hyperMILL, and I figured to go ahead and publish it and share it and see if it's useful for anybody else. So we're going to dive right in. This is totally unscripted. I have no idea what I'm doing. Fly by the seat of our pants. Let's give it a shot. Okay, first thing, we are looking at the sort of default hyperMILL setup here. Let's spend a few minutes talking about navigation, where we're at, where things are at. First thing you're going to want to know, up in the hyperMILL tab in the top, info, hyperMILL help. All right, if you click this, it's going to take you to an external web link, and just about every function inside of hyperMILL has some text blurb that will attempt to help you understand it a little bit better. The other thing that's important about hyperMILL, if we go ahead and click this, it's going to open up a dialog window. This is important because it lets you know what revision or update you're at. I'm at 2023.2 right now, update 7, update 1, 8.1 is live right now. There's some decent enhancements between 7 and 8. I'll make that jump pretty soon. Typically speaking, if I have projects in progress, I usually wait till I have something I'm happy enough with that I'm running to update, just in case there's any undesired side effects with the update. So that's a little bit about hyperMILL and HyperCAD-S. All right, default hyperMILL layout. Maybe okay to get started. Usually the AEs will share their default layout with you. I operate on a couple different monitors, so you can break these windows down and pretty much pull them anywhere you want, including other monitors. And once you have a setup you like, if you go up to File, Options, Layout Manager, and you go to Save Current Settings as Configuration, you can get hyperMILL to kind of save where you have all your windows and the sizes and everything like that. It works for just about all the different panes, with the exception of a couple of the different tool panes can have some strange behavior. By default, I have this restore configuration settings. So if you walked up to a computer running hyperMILL and it was at this default factory layout and you had a layout saved, restore configuration settings will recall your saved configurations. Now, depending on what file pathing you're using, these settings are typically saved in a, I want to say it's like a local users folder. You can copy that path. I believe you can even change that path, but don't quote me on it. Something I do, I remote desktop a lot. And when you remote desktop to a computer that doesn't have the same screen layout or resolution, things can get really wonky. So something we'll talk about eventually is just hotkeying stuff. And I made this Control W hotkey for restoring configuration settings. So when I get on another computer, I open up hyperMILL, I Control W, it just instantly gets me back to my layout. On the screen here, you have a lot of tools, and depending on what type of work you're doing, what type of files you have, different things are going to be important to you. So it's important to know a couple things. A, I'm going to show you what works for me and what I've found is helpful. And B, in hyperMILL, there's almost always 2, sometimes 3 or 4 ways to do every single thing inside this piece of software. I'm going to show a way, either the way I was taught, the way that someone was doing something but with my own twist on it, or just whatever I've found physically works for me. And that includes getting rid of some of the stuff on the UI here that ultimately I didn't find as helpful for the way I was using hyperMILL. What is going to be really important to us over here on the right side of the screen, layers, okay? You have this layer dialog window. This is our bread and butter. If you like to have a really organized CAM workspace as it relates to all your drive geometry, surfaces, work holding solid body, then you're going to want to really leverage the layer functions over here. And as we get a little further down, I'll jump into some of the templates that I use, and I break them. You can have containers inside containers and containers, and I break down different operations. I put all my work holding together. I put all my geometry together. I put surfaces together so I can quickly switch between different operations. Colors. This is another way to sort or view or select stuff inside hyperMILL. Could be particularly useful for you if you're working using feature recognition a lot. That's where the color mapping can have a pretty significant impact, wherein when we do feature recognition, we can assign colors to stuff and we can turn around and drive macros and some of the tools in Automation Center based off of the colors of different features. You know, metric threads of this size or this color, inch size of these threads or these colors, surfaces highlighted pink default to certain toolpath tolerances versus green. It can get really, really in depth. I would say for 95% of users, we don't care about colors. I completely minimize it. And that kind of goes along with tags, user-defined tags, and stored filters. Those all are really similar tools that are powerful in the feature recognition and automation space, a little less for the typical guy sitting down to bang out a part in hyperMILL where you intended in programming from the beginning to the end. Up above that, we have entity visibility. This can be useful. I let it exist, but it's usually not super prominent. 99% of the time for me, we have everything turned on here. I'm looking to work with just about everything because I'm putting different types of entities in different layers. So if I want to hide or illuminate surfaces, I'm just going to really quickly do that depending on my layer setup. Is it a drive surface? Is it an extension surface? Is it a cap surface? I kind of have those categorized down inside the named layer area. So when I get ready to set up hyperMILL, this layer box pretty much dominates my screen. In addition, a year or two ago was bookmarks, and we'll get into bookmarks. Bookmarks are actually super cool, probably a little underutilized, but you can think of a bookmark in the CAD workspace, in the hyperMILL or the HyperCAD S workspace, doesn't impact CAM, as a snapshot in time. So your screen orientation, your view orientation, the colors, the transparency, what layers you have activated, you can basically take a snapshot in time. You can get 30 minutes down the road programming and say, hey, I remember this view or this point in time or what I had turned on at this point was useful for me. If you had that bookmarked, you could quickly click it and it's going to turn on and off all the appropriate layers. It's going to reorient your view and kind of get you back to that moment in time. I find it particularly helpful for different operations. I like to program all my operations in one file. You're going to get mixed reviews on that. If you have a really good computer, you're working locally, you're keeping a tidy CAD CAM file, then programming everything in one file is awesome. The stock model is easily user generated and transferred between different operations. Because you don't inherently have the sort of parametric nature of something like a Fusion 360, where if you make a model update, it's going to update everything connected to that model. The way that we're running hyperMILL here right now, this model and this file is sort of sacred. So when I do multiple operations inside of this file, that all remains tied together. Now, people that will get into a little bit of trouble on that, if you have incredibly large work pieces, you're working on a gantry mill, if you have really complex, challenging molds with an incredible amount of toolpath data in one file. Step overs, just single digit micron step overs, or just a few tenths, and the density and the amount of data can become a little overwhelming, and there's cases where you have to break it down into multiple files. For the job shopper working on 5-axis parts, even through 2, 3, 4, 5 operations, if it gets that heavy, doing it all inside of one file, I haven't had any issues with. This computer is 128 gigs of RAM, an RTX Quadro 5000 series, which I think has like 8 or 10 gigs of VRAM, GDDR5, maybe 6 even. I think we're running, is this a Ryzen computer or a Core computer? I think this is a Core computer, i9. Oh, I don't know, whatever the current generation was for the end of 23. Something Lake or Ivy. I don't even remember what we're on now, but I want to say something to the tune of like a 4 gigahertz base clock and a boost clock that's up near 4.5. Eight physical cores, maybe 10 physical cores plus hyper-threading. I would open my resource monitor, but because we have a lot of customer proprietary stuff on the computer here, I'm going to intentionally not do some of the file navigation that I might talk about with you guys, just so I don't accidentally release any customer information. Anyway, continuing on, CAD tools, we're going to come back to that in the upper right-hand corner here. On the left-hand side, this is our CAM workspace area. We see 2 more tools down here, selection tools. I close these out. You actually have these same selection tools down in the lower bar here, as well as up here there's some filtering options for groups, sketches, features. I don't find those very useful. This is where you're going to spend all of your time in CAM, is this hyperMILL work window over here. So we have some CAD utilities on the right, we have hyperMILL on the left, and again, this can all be broken out and moved around and put in different areas so that it works for you. CAD tools, all right. This is a selection of the most commonly used CAD tools grouped together for you. It's going to help you maybe get started, but what you're going to find is sort of these groups, these surfacing tools are part of a group, these curve tools are part of a group. You're going to want the whole group. So I actually hide the generic CAD tools group. I just close this box out and I right click in this upper gray bar up here, and this shows you all the different toolbars that you have available. So one that's important to us is hyperMILL tools. I go ahead and open that up, and you can place that wherever it makes sense for you. If you hold down the control key and you're inside of a toolbar, and it's not going to work for me right now, I guess you got to be over an icon, you can use your center mouse wheel to make these bigger and smaller. Now, because this toolbar is sort of a defined space, the effect you're seeing is insignificant right now. You'll understand in a second here why that's useful. So let's add some more tools. One of the ones we're going to use a lot is the curves toolbar. So there's our CAD toolbar that we just had. Curves toolbar. Where did that guy go? It opened up, but it snapped somewhere weird. Oh, okay, it's over here on the left-hand side. You'll see there's a lot of empty space in this toolbar, and we can actually add more tools in this same space, and that's when making these icons bigger and smaller becomes important. If you have a really big monitor with really high resolution, maybe you want to zoom in on these icons so you can see them a little bit better. If you've got great eyes and you want to cram more into a certain space, we can leave them small. Now, what's important to understand is all of these tools are available from these drop-down menus up here. And what we're doing basically is, for those of you that can kind of have that visual recognition, we're going to save moving all the way. First step is get out of going into all these drop-down menus when we want to try to be a little bit more efficient. These tools help with that. The next logical step is get these all hotkeyed and start to memorize some of the hotkeys so that we can keep our mouse from going all over the screen. But we're going to start with adding a couple of toolbars. The workspace is going to get a little busy. It can get a little overwhelming. I am a firm believer in a multi-monitor setup for CAD programming. Break this stuff out. I really like to have just my workpiece and my CAD tools on the screen in front of me. I get all the visibility tools and cam stuff off on other screens because it's kind of just too much crammed into the space. But here are our curve tools, toolbar rather. Excuse me, the stuff that's significant to us, boundaries, that'll be important. Another thing we're going to do is the average curve is pretty commonly used, offset's pretty commonly used, and the projection function is pretty commonly used. Isoparametric is going to have its uses, some text projection. If you need to drive lines through center of cylinders, some of this other stuff, there's cleaner ways to do it. Joining curves can be convenient if you're not using the chain command, I suppose, or if you're ending up with just a ton of curves that are tons of little tiny segments. So what we're going to find is some of these tools, particularly like spline for me, this helix function, I don't use at all, and we can get into customizing these toolbars and actually getting rid of buttons we're not using. But we're going to leave it sort of default right now so we can actually get in and do some work. The other big one, drafting toolbar. If you're making fixtures, modeling, annotating, that one will be useful for you, excuse me. I don't use it hardly at all. However, what toolbar did we just turn on here? Workplane toolbar, we'll get to that one. I want to go in order here. Edit toolbar also has some useful utilities, particularly mating functions. If you're wanting to create some work holding that has mating functions or automatic mating, that's important. Breaking down text into curves so we can drive engraving. The break function becomes pretty important. Table here is our spreadsheet table. This is awesome. It's basically a mini Excel spreadsheet inside of hyperMILL where we can store values, and hyperMILL absolutely has some parametric drive functions that we can go back and use the spreadsheet for. That's pretty high level stuff. We'll see what we get. Group and ungroup, that kind of works together with the mating function when we want if you have a shank vise where there's a lower jaw carrier and an upper jaw, you want them to move together as a group, you might be using functions like that. But not something that we're going to leave up on the screen full time. Feature toolbar. Some basic feature stuff. Really what I pull out of the feature toolbar typically is the linear protrusion and linear extrusion. Occasionally use the whole feature. Fillet and chamfer are also pretty popular, but not used frequently enough to warrant real estate space. File toolbar is the next one. Save, copy, your typical stuff you get from the drop-down menu, not wicked important. Filter entities, more filtering tools. If you have big models, complex assemblies, it offers some of the same tools we've discussed kind of over here on the right-hand side, down at the bottom here, and some of the stuff that was on the left-hand side of the screen that we hid. Just a way to get visibility or selection of just certain types of entities. Help toolbar is exactly what it sounds like. This opens up some of these help functions that we discussed. Particularly in the CAM workspace, you can right-click anytime and go to help immediately. The CAD workspace, you'll have to actually go through the file help menu to get info on a certain tool. At least as far as I know. I could be misspeaking. hyperMILL toolbar. Some stuff in here that may or may not be useful to you. It's the same stuff that's down here. We have it duplicated already. I think it's got everything the same. I'm looking, it looks like yes. Your bread and butter down here are absolutely your clear tool path, as well as actually some tools that aren't down there, which are the virtual tools. That's mainly a friend of the Automation Center tool database, open function. I run the tool database open on a screen next to me. That'll be something we'll cover a little further down the road. HyperView, this is the legacy simulation toolpath viewing tool, not really used anymore. If you're up on maintenance and you're using hyperMILL these days, you're using Simulation Center or virtual machine most likely. Adjust paths pairs along with some other things that we're going to cover when we start setting up our CAM workspace, but it is going to be essential as soon as we start programming that we have all our file pathing set correctly. hyperMILL by default, okay, I'm going to add a caveat there. Depending on how you set hyperMILL up when you first did your install, hyperMILL can operate in a few different ways. The most vanilla way is it uses a local temp folder for a lot of the toolpath data storage, which means every time you're opening and closing programs, that data could have been erased or overwritten. So we're basically going to take our CAD model, put it in the file where we would like to have all the data go, and then path all our CAM data to that same file so everything stays together, which means when we open it up on different workstations, or we send the file off to support, or we're one of the few people that have decided to work on a server, we have our toolpath data already generated, stock models and everything are happy. The CAM file can find all of that data easily. Again, kind of duplicate on the bottom of the screen here so the hyperMILL toolbar doesn't get any real estate. Toolpath properties, this is not a tool I've used very often, but if you're really interested in viewing the physical toolpath itself, there are some tools up here to see different portions of the toolpath. hyperMILL Utilities toolbar. We have more read toolpath. I'm going to be totally frank with you. I have never used any of these utilities in my entire life. So I am not going to comment because I don't know how they work. Markups toolbar. Never used it. Skipping it. Modify toolbar. Modify toolbar is your bread and butter in hyperMILL. This toolbar contains some stuff that is incredibly useful for both curves and surfaces. So we have a few functions here, right to left, break shape. Okay, if we have a solid body that we want to modify and some of the inherent solid modeling tools are not giving us desired results, we have actually pretty incredibly powerful surface modeling inside of hyperMILL, and we can use the break shape tool to take that solid body and break it into its individual surfaces and then do all sorts of stuff with those surfaces. The other super useful tool, trim faces. This will allow you to take a surface and use a bisecting surface or a piece of geometry or a few other entities to cut, splice, divide that surface. Next to that one is the untrim faces. So if you think of a plane or a fillet as this surface that exists in a certain size and position to fill the gap that is required, and we want to stretch that out or unbound it, we can use this untrim faces, and it will sort of revert it to its natural geometric shape, or at least turn it into an unbound or untrimmed surface that we can then extend and modify as we see fit, which works really well with the extend shorten face tool, which typically only works on untrimmed faces. to get extension surfaces on a face that is bound or trimmed, or the basically the non-native face. There is some extension tools that we'll use instead. The last two, split face and continuity face, don't use as often, so we're not going to spend too much time staring at that. There's some NURBS tools in the middle here that I find myself using a little less, but the utilities are kind of what they sound like. Converting different curves to NURBS, or switching the vectors of curves might be useful for what you're doing. I find is, in most of the toolpaths have some of this functionality built in natively. So if you want to reverse vectors, usually can do that right at the toolpath. You don't actually have to switch around surfaces or actual drive curves. Maybe those have a place. Maybe they exist from legacy stuff before toolpaths inherently had a lot of those capabilities. Over here, modify arc line circle, not super useful for me, but it's just what it sounds like. Depending on the type of geometry you have, the dialog box is going to change a little bit. What I do find is automatic trim. I have two lines that intersect one another and extend beyond one another. This trim is just what it sounds like. If you have this highlighted, you go over to a curve, it will sort of highlight whatever side of the curve you're on and allow you to trim off that excess. Trim curve does something similar yet different. It's basically a non-automatic version of this, where you're selecting the curve and kind of selecting which side you want. Automatic kind of determines it depending. This is important because contextually, hyperMILL will do this in a number of situations. Depending on the side we approach a curve or surface from is how hyperMILL is going to know what side of the surface it was our intent on keeping or deleting. Over to split curve. If we want to take those two same curves and we want to keep all four curves, but we want them to be four separate curves, we'd use that split function where we can use one curve to split the other curve without deleting any of them. Extend, shorten curve. Geometry that we create that is drafted geometry, we can just double click on, make it longer, make it shorter, increase the radius, decrease the radius. Curves, because they might not, oh God, there's a word for this. I'm trying to think of the word. The curve might appear as a uniform geometric shape to us, but maybe it is more spline-like or conical. The extension of that curve might not be complete a perfect circle. It might actually go off into space in a weird direction. So this extend, shorten, curve function, I don't know what exactly it's doing in the background, but it kind of reads about how the curve was created, I would assume, and sort of the ISO points and drives the curve onward depending on how the beginning of the curve existed. Continuity curve, basically taking curves and blending them together with parameters. Modify control points. If you have a shape or curve that's obviously not geometric, when it was created with a number of these control points, maybe in the foreground, maybe in the background, depending on what tool was used to create it. This sort of highlights those control points and lets you drag them around. All those points are weighted, and depending on how you move them, changes the way the curve looks. So that's the modify toolbar. We're going to leave the modify toolbar active because the modify toolbar is awesome. I am going to mouse over that though and make those tools a little bit smaller, and I'm going to grab this curves toolbar and put it up here next to this. So you can see I grabbed on those three dots, and it allows me to manipulate that and put it in different areas. Right click again. Rotation steps. I don't use this at all. 3D mouse. Super highly recommend a 3D mouse. If not, you have your middle mouse wheel, you have your right click function. Control plus right click is pan. Just straight right click is rotationally. And I am going to misspeak here, but I'm going to make a comment, which is I think the hyperMILL drives the center of rotation based on the mass of the object. With the caveat, I believe you can right click. There's a way to do this. Ooh. Shoot. Set? Oh, I don't want to misspeak right now. Certainly, where you have your cursor and zoom in and out, that's where your zoom in and out weight is at. Okay. So maybe wherever your right click your cursor is, that would be your center of rotation. I'm not. Don't quote me on that though. You're going to have to manipulate it a little bit and get comfortable with what works for you. I use a 3D mouse, 3D Connection Space Mouse. It's fantastic. So, no on rotation steps. Selection toolbar, not super important for me. It's exactly what it sounds like, giving you different tools so you can select certain objects. If you are working on a string of fillets and there's like 900 different fillets all connected to one another and you're trying to drive, pencil tool path, you might want to select all the tangent fillets. I've never really got myself into a predicament where I was clicking shit for hours on end. You can duplicate surfaces, you can group them together, you can do all sorts of cool stuff to make reselecting them easy. So those maybe those are useful for you. For me, we're gonna skip it for now. Shading toolbar. How do we want the model to look? I pretty much am a solid with edges guy. I do have the global transparency button right up on my toolbar here. I find that is extremely helpful, but I almost never go. I know some people like the shaded with hidden edges. Yeah, that's not really for me. I like to see the clear, geometrically defined edges of my model. I am, for the most part, a drive from the model guy, despite the fact it will kick your ass in some situations, particularly if you're updating models. Now, there's some best practices there. The gist of it is, if we take the time to make all our own geometry on here and drive toolpaths from that geometry, we can we can take this model, we can punch holes in it, we can make it bigger, so we can do all of these things. And at least for the toolpaths that are driven off certain pieces of geometry recreated, those will sort of stay together versus things that are driven off your 3D model that are modified. As soon as you modify the model, you're going to break them. Now we're going to talk about best practices, creating duplicate models, leaving the customer model sacred and just modifying those duplicate models. That's going to be pretty important. We'll cover that one when we get there, but that was a really long way of saying shaded with edges. That's my go-to. I don't leave the shading toolbar up there. Next, shapes toolbar. Shapes is one that lives on my screen. It has some tools that I use all of the time. I will also recommend, if you are using shapes a lot, you probably ditch this bar and kind of filter down to the tools that are important to you. Plane. We're going to use plane all the time. We're going to use it for everything. Bounded plane. So whereas a plane, we're just going to create somewhere in 3D space, usually parallel or perpendicular to our work coordinate system, our gnomon, our active work plane. A bounded plane is actually driven from geometry. Now, all of the geometry for a bounded plane needs to be planar for bounded plane to work correctly. Linear sweep. Linear sweep is taking an edge, a curve, some piece of geometry, and sweeping it off into space. We can drive the vector with curves, with points, relative to the world coordinate system, relative to an active work plane. Awesome tool. And Swept-Plane has a other cool utility, which is that we can make it completely enclosed and turn it into a solid right at the CAD tool level. I'm sure we'll cover that when we get there. Rotational, it is the same as a swept plane where we're taking geometry and driving it, but we're driving it rotationally around points or a vector or our work coordinate system. Ruled. Ruled is ruled, kind of creating a surface between two pieces of geometry. There are some rules regarding ruled. When we get there, we'll play with that a little bit more. From boundaries I use as well. From boundaries is similar to ruled, but ruled has some rules because it's designed to create a surface that has, I believe, a little bit more strict isoparametrics between boundaries will give you different results, and you can create some quite bizarre shapes that don't follow the same rules. As does filling. Filling is like the final step in the bizarre surface created. You can select a bunch of different pieces of geometry in wildly different points in 3D space and use some basic weighted tools depending on their relative position or tangencies, and it will give you a surface 99.9% of the times. Now that surface might be so bizarre you can do nothing with it, but if you're really trying to get a surface created between several pieces of geometry, even geometry that's not connected, filling will give you something. Offset is an awesome tool that we use a lot to support CAD, particularly, I find. If I'm in an area or a situation where I need to be driving a toolpath or avoiding something, sometimes the easiest thing to do is create some offset surfaces and kind of tell the toolpath, hey, we're not going to violate these surfaces. Through selections, this is basically where we're going to follow a bunch of line vectors to create our surface. Along a guide is just what it sounds like. We're going to basically something ruled-esque where we're going to pick some curves that give us the shape we want, and then we're going to extrude them or traverse them or sweep them along a guiding curve. All of these tools I use pretty frequently. From here on out, we're going to see some different ones. Helical face and blending are not tools I use a lot. Join can be super helpful when we have a ton of surfaces and we're really trying to unify or unite common surfaces that are tangent or have UV vectors that are all driving in the same direction. Instead of clicking 5 surfaces, we just want to click like this one large surface. It's only going to let us connect surfaces that are tangent, that do have similar UV vectors. Sphere, cylinder, cone, don't really use them. I guess if you're doing a lot of surface modeling inside of hyperMILL, those tools might be useful for you. I don't use them. Patch holes. Patch holes is great. Oh, close holes. Excuse me. Is an awesome tool. It's exactly what it sounds like. We're going to select a surface. I want to say it has to be a planar surface. And it will generate hole patches all over that surface for them and put them on the same layer for us. Swarf cutting, I don't ever use this. The swarf cutting toolpaths are super easy to drive in most circumstances that I find myself using them in, but I don't have a ton of experience. I'm going to imagine this is actually kind of like a guide curve S sort of thing where with Swarf you typically need some side surfaces and a piece of geometry to drive the tool. And I guess that's what we're achieving here inside of this CAD tool, but that's all I can say about it. Never used it. I mentioned earlier that when we have trimmed faces that are bound, we want to extend them. If we don't use the untrim function and the extend face function, we can use this tool, extension faces. Now this is something a little newer on the last couple years, and this is an awesome tool, frankly, where we can select a face and have it give us extension surfaces around that face or just specific boundaries. Now, that was a perfect example of contextually, I had my mouse here in this area, I drove it towards the edges. If we reset, if I did that same thing and click here, it's actually extending it, tangent coplanar to this top face because that's where my mouse came from. And global fitting. Global fitting is a pretty neat tool where we have a bunch of surfaces that have some sort of, I want to say like semi-relevant tangency, but maybe vectors that are off in all sorts of different directions. We find this really commonly in orthopedics, where they've done 3D scans of human bones and actually made bone plates based off those scans. The tools that they use to go from that 3D scan data to supplying us with a solid model usually means we have a ton of wild surfaces with vectors going all over the place. And sometimes, not always, but sometimes we can take a lot of those surfaces, and global fitting basically it gives you a few different tools depending on if you want the surface to be very accurate to the parent surfaces, or if you want it to kind of soften the tangency between the surface. It has a bunch of cool tools. And essentially, in the end, it's going to give you a uniform surface where you can define the direction and orientation of the UV vectors, which can be massively helpful for getting really clean tool paths driven off of patched up surfaces. Excuse me. You're going to see a fillet and a chamfer tool, just like in features. Features are designed to modify solid bodies. These fillet and chamfer tools are designed for working with surfaces. I do use these tools, particularly when I have a 3D solid model that for whatever reason, whatever native system it was made in, I get it into hyperMILL. Maybe the model was modeled up with fillets, and I want to do a function with the sharp corner, or conversely, it needs fillets and has a sharp corner, but for some reason, it's a weird connection of surfaces or a strange bit of geometry, and hyperMILL can't, or HyperCAD can't use the feature fillet tool to get us the feature we're looking for. Sometimes taking that shape, that solid, breaking it into its surfaces, we can get a little bit different results with the filleting tools in the surfaces. And once we have a surface model we're happy with, we can turn that back into a solid. Another super useful tool, we talked about breaking shape. So that's taking a solid model and breaking it into its surfaces. Here we have the create solid. We're taking the surfaces, we're building them back in to a solid again. Faces from mesh. This is going to be just for a small group of users that are working with meshes. It's exactly what it sounds like. If you had a STL file or something and you're trying to get some usable CAD CAM surfaces off of it, you could use that tool. It's still kind of challenging. And one that I use every single file, create bounding box. This is awesome for quickly taking apart, finding out what volume it occupies, using it to figure out what size piece of material you want to buy, or what machine it'll fit in. Throwing a bounding box over it real quick and kind of establishing how big of a part you're dealing with can help you make those decisions. So the shapes toolbar is going to live up top for us because we want that one. Snap toolbar, let's see if we can blitz through the rest of these. It's all the buttons that are down here. We're not going to worry about it. You're not going to have any problem, for the most part, clicking on what you want to click on. Tags toolbar, we're not even going to open up. We're going to skip it. It's another sort of tool for filtering or automation where we can give stuff certain names and find stuff by those names. Turn machine views is exactly what it sounds like. That was more helpful when we were using, oh shoot, we just talked about it, the legacy toolpath viewer machine simulation tool, HyperView. VSketch toolbar. VSketches are our newer addition to hyperMILL. V-sketching is parametric sketching inside of hyperMILL. So we're driving lines based on parameters. So when we modify those parameters, we can make a net change in our shape, just like in SolidWorks or NX. If you model something 10 by 10, you create your solid, you're 20 steps down the line, you go back and make it 12 by 12, it's going to update the solid model you created and everything thereafter. I would say that is probably a tool I don't know a ton about. I have used it a little bit. What's important is, and this used to be the case, and hopefully I'm not misspeaking, you can't change regular drafted geometry to a V-sketch. It needs to be made as a V-sketch from the beginning. That's just important to know. So if you want to be using the parametric functions built into hyperMILL now, you need to be V-sketching everything. Regular drafting and turning it into a V-sketch didn't used to be an option. It might now. View toolbar. Has a transparency tool, which we discussed a little bit here. The rest of the stuff I don't find super useful. This little airplane looking guy, that is useful. So it just says defined here, but this is basically the tool that we can use to slice through our model. So also up here in the view toolbar, clipping plane is the word I was looking for. So if we want to cut our model exactly in half, this is the tool we use to define our clipping plane. You know, we can have it make the geometry solid. You can slice your model and your stock differently. If you're working on any sort of parts that have crazy internal geometry or ports and you want to slice stuff away and see stuff, this can be a really cool tool. And then you can create these different clip planes with define and actually activate and deactivate them. These two buttons here are buttons that I've added that didn't actually default when I redefaulted my screen, so I could show you guys what the default looks like. But we'll discuss adding those because they are both super useful. The rest of those I don't find so much. Visibility toolbar. This has some color stuff, hide, unhide. H, Control H. You're going to live on those two keys. Hide, H key, unhide, Control H key. Workplane toolbar, Workplane toolbar. These are all useful. The one that you are going to memorize is Shift S. Shift S and V. So you have Workplane on a face, and then you have Workplane normal to view. So that's all of those times, particularly in the 5-axis workspace, where if we envisage ourselves as the spindle and we're looking through the tool holder down at our model, we're kind of establishing like, yes, this is the vector that we want the tool coming from. We could quickly snap a workplane on that face, okay? And then if we use the V key, it has now oriented that workplane normal to our view. The other one we're going to learn to live and love, Control 1, that is view normal to workplane. Everyone's going to have their preference. The quickest way for me to navigate things inside of hyperMILL and HyperCAD is to quickly put a workplane on a face and then to quickly establish my view normal to that workplane. This workplane means absolutely nothing to anything until I make it mean something. And that means to say I can create it anywhere, I can move it around, I can put it on this face, I can put it on that face, I can save workplanes, I can do all these functions with them, and it doesn't mean anything until I tell hyperMILL this workplane is of significance. I turn it into a basically the native work plane for a tool path, or I select it to use as the vector for a tilt curve. You can do a ton of cool stuff with it and manipulate it and move it around. That is going to be a super useful function, and that ties in with something we have over here on the right hand side, which is the Workplane tab. And if you're one of those people that really finds yourself wanting to go back to a certain orientation again, you can take that work plane, you can go up to the work plane area, and you can save that work plane. We can give it a name. We'll call this 1, 2, 3. All right, and we see work plane 1, 2, 3 has saved over here. So as soon as I generate another work plane on this side, you're going to see this gray phantom. This work plane exists forever now over here. And I can turn it off, I can turn it on, I can double click it to reselect it, reactivate it. Those functions you're going to memorize because they are so important. That being said, you can set it to world, to view, through vectors, on a surface, on a curve, relative to different planes, however you need to use it. You will find that on your view and normal to a surface are 99% of the time what you're going to be using. So I don't actually leave the Workplane toolbar active. Workplane views, which kind of go hand in hand with the Workplane toolbar and orientation. This is where this goes hand in hand. Why putting work planes on faces and setting your view normal is, I think, a great way to navigate is, again, because we can do something without ever having our hands leave our keyboard or our 3D mouse, which is if we use the Alt key and X, Y, Z, we can manipulate the work plane around any one of its vectors. So instead of memorizing or activating all of these different views, if we just remember that Control 1 sets our view normal to our work plane, I find it's way quicker instead to snap a work plane on a surface. So we'll put it up here. And then quickly, I want my view to actually be normal to that front plane, or I want to look across sort of the bow of the plane that my work plane's sitting on. I'm going to just quickly tap the Alt key and X, and it's going to have rotated around that. And when I Control 1, my view is normal. And I could turn that around Y as well, Control 1. I can do it around Z as well. If I Alt Z, well, right now, that's going to provide the same result for us. But those are my bread and butter. Work plane on face, work plane normal, or I'm sorry, view normal to work plane, and then the keys to manipulate the work plane around any one of its axes or vectors. And that just becomes useful, almost it gets compounded because you can quickly project geometry from different faces to that work plane. So being able to flip your view around, set that work plane on different surfaces really quickly can help you get the geometry and surfaces where you need without diving into different menus or memorizing a ton of different keys. And lastly, world views. This is going to be exactly what it sounds like, all native to your world coordinate system. Now, one of the beauties of hyperMILL for me is that CAD and CAM do not care where your world coordinate system is in. Everyone has gotten models from a customer that are part of an assembly, and they are existing somewhere way out in space. It doesn't matter. We've already talked about how our manipulation of the model is weighted off the center of gravity, so we don't have to worry about manipulating this model and having the rotation point be somewhere way out in space, with the caveat you can actually make it rotate around other points, and you can do that unintentionally. And whatever we define as our NCS and our relative coordinate system is how all our toolpath geometry is going to be driven, how all our clamping points and our work coordinate systems are going to be driven for simulation and post-processing. It does not matter where the world coordinate system is. However, if you would like, you can take your work plane, you can set it on world, and it will drop it to the gnomon of your world coordinate system. So we're going to keep that hidden. I don't know how we're doing on time right now. I don't want to drag this out too long for you guys. So I think we'll call it there. That's kind of introduced you to what's going on the screen. I guess it'll be important for us to cover real quickly on the bottom of our working area here and in the top of the gray pane, there are some of the tools that are pretty useful for us. This is the tool that we're going to use to move existing geometry, solids, surfaces to the layers that we want the part on. I create a new container. I create a new layer in that container with the right-click context menu. Right now, my model is on this layer 1 here. Now, if we stretch this over a little bit, you're going to see there's our entity. So we have one entity, okay, and it's on layer 1. If we turn on off layer 1, it's going away. So if I want to right-click in here and rename this, I'm going to call this one customer model, okay? And I want this to be in the customer model. I can select it a couple different ways. I'm going to use the B key, B as in Bravo, for inherent solid selection. B key, I'm going to click on my solid, and then I can use this layer menu here and click customer model. And if you watch the entities up here, we're going to see this entity move from what was layer 1 down into customer model. And sure enough, there it is. Now, you're seeing two values here because at the top level, container 1 contains one entity. Now, that one entity is in customer model. Then I can come back up here and I can delete that old later. Default always exists. We can't delete default. Everything that we create without having a default or a defined layer will go into default. If we would like to make another layer the de facto layer for whatever we're doing, whether it's creating geometry or surfaces or duplicating a solid, we just double click that. You're going to see that it becomes emboldened, and that lets you know that is the de facto active layer. So that's kind of the layering tool. Right next to that, we have the colors. These are colors that I have already defined. The default hyperMILL color palette looks a little bit different. We'll cover that later on, but we can select the solid model and we can assign a color to it just like that. Then we have line type, whether you have hash lines, dotted lines. I don't use that very frequently. Afterwards, we have the line weight window. So this is basically the visibility of the lines on screen. I like to keep mine really thin and sharp with a high resolution monitor. If you're working on a workstation out on the shop floor and you have poor resolution, it might help to increase that line weight a little bit and get a little bit better visibility of where the edges of your model, surfaces, geometry, etc. are. Afterwards, we have one of the selection filters. Again, this you can use this as a toolbar. I leave it on automatic. hyperMILL's default selection sort of intelligence is pretty damn good. The one time that it won't work at all is if you're trying to select a toolpath. If you have a toolpath and you're trying to select the distances, natively toolpaths are not selectable. All you're going to do is drop down here to toolpath polyline point, and then you can select a distance between toolpaths while they're active on the screen. This button is incredibly important for us, and this is enable, disable snap point projection on Workplane. This boils down to what are we doing? Do we want it to happen on the Workplane that is on our screen, or do we want it to happen wherever it exists in 3D space? And what I find is 9 times out of 10, if I am creating geometry or surfaces or anything along that nature, I have put my Workplane in an area that is of importance to me and where I want that stuff to happen, and I want that geometry to be coplanar or exist on that work plane. So I will have that box highlighted yellow. For the times I don't, you deactivate that, and that means, for instance, if we were going to offset this curve here, it might just offset it in 3D space relative to the ISOs of this surface versus automatically happening on the work plane that we're on. And we'll find, as soon as we get into some programming, some stuff, it'll become immediately apparent why that's important. We have the copy attributes tool. Never used this in my life. Absolutely no idea what it does. Likewise, graphic properties, not used very often, except in when I do some micro machining stuff, particularly like on we have a couple of super high precision small 5-axis machines. When you're super zoomed in on something, particularly something really small with a lot of geometry, you're going to start to see this, and I'm not even sure if we can see it here. Let's change the line weight here and see if it highlights that at all. You can just barely start to see some tessellation where that line actually, and here we can see it better on the corner here. We can see this is, I believe, referred to as tessellation, where basically in the background, nothing is perfect. Everything is, theoretical. Curve exists here, and there are a number of points, and we're getting displayed a representation of that curve. If everything was exactly perfect, it would bog the system down to make your computer almost unusable. When we're zoomed out, that looks like a nice little curve, but when we're zoomed in, it's really poor. If we want to, at the expense of processing speed, taxing our computer's hard drive and graphics card, have that display more crisply, if we have whatever we're wanting to change selected, so I selected the solid there, and we right click and we use that graphic properties function that is that little pencil down there, you can see some information here. Firstly, the layer that's active, which could be relevant, the color, some isoperimetric information, but what we care about is the face tessellation tolerance and the curve tessellation tolerance. Now, right now this face actually looks pretty good, and sure enough, the tessellation tolerance is, I believe, we are set to millimeters right now, so that's just 2.5 microns, 2.5 tenths of a millimeter. However, the curve tessellation tolerance is pretty high, so if we turn and set this curve tessellation tolerance to a lower value and click outside of this box, we see that it's actually added some more points along here and made that geometry a little finer. And you can keep hammering that number lower and lower and lower. Just don't be surprised when you have a complex model and you go to manipulate it and it just drags you to an absolute halt. So that might be important. What you need to understand is the tool paths you're getting, and I'm gonna make a blanket statement here that I hope I don't regret. In just about every situation that I'm aware of, the tool paths that are being generated with respect to your toolpath tolerances against the 3D model. The way it looks on the screen does not matter. If you have a part that you know is a round 3D solid or model, and you set the tessellation tolerance to be really high so it looks like a friggin' octagon on your screen, you are going to get a toolpath that creates a nice round 3D or 2D shape. It is not going to give you an octagon, and that should be immediately apparent in the code you're getting. Now, hyperMILL toolpaths, the way they're generated, they do different things based on the solid model. There are some functions in some higher level 3D surfacing and 5-axis surfacing tools where we're actually, hyperMILL will take the surface and generate a point cloud and drive the toolpath from this point cloud, so you get this really nice distribution of points. Other stuff is driven off the UV vectors and the model isometrics. There is, I believe, if you deep dive into view and analysis, you can use some tools in Zebra and some other things to actually see all the ISO directions. And you know, this whole thing is a triangulated mesh. Even this block in front of me is all made up off of triangles, and there's a lot of math and fancy stuff happening in the background to get the toolpaths generated based off of all that triangular mesh. But what you need to know is you're getting good, clean G-code off your part regardless of how your part looks. Now, there's somebody out there that has an actual fucked up part, and you know, that's going to create some issues. But myself, and I'm sure others at some point in time, have asked, oh my God, this model looks like crap, is my toolpath can... No, it's never been the case for me, and between all the users I know, that's not the case. You're going to get good toolpath code regardless of how the model looks. And I'm going to say regardless of how the toolpath looks. Now, obviously, that's a much more brazen statement, and the point I'm trying to make there is, if we have lines on our screen that are clearly going in bizarre directions relative to our model, we're going to see ugly machine motion and a poor toolpath. But if we zoom in on the toolpath and we see that same tessellation, that does not mean your toolpath is zigzagging back and forth on your part for the most part. Now, that does get... The toolpath is a little bit more of a sensitive subject, because some of the stuff you're seeing is just visual artifacts and how well the toolpath is rendered. And in some cases, it actually is getting you in a little bit of trouble, and experience will really help you weed that out. There's not a real cut and dry line in the sand there. And lastly, we have a face tessellation thing. It's just a slider for how nicely our model is tessellated. Okay, that took a little longer than I had hoped, so let's blitz through the top here. New, open, save. I don't actually know. Close. So if you want to close this file, but you don't necessarily want to close the hyperMILL utility. Settings, we're going to dive into settings. Drafting settings, we'll dive into that. Entity properties. So this is, I want information on this surface. Two entity properties. I want information about this surface relative to this surface, i.e. the measuring tool. Not great when it's fuchsia and your part is fuchsia, but if your part was white per se, it would probably appear a little bit nicer. So that's our measuring tool. We're going to use that pretty frequently. That's a super useful tool. Undo, redo. Undo, redo only works in the CAD workspace. In hyperMILL, the way we're going to learn to run in modeless, your decisions are final. And hyperMILL is going to tell you, hey, are you sure you want to do this? As soon as you say yes, there is absolutely no going back. To include, even if you've saved, sometimes, depending on your action, reverting to a save might not necessarily get you something back. If you've deleted a toolpath file or stock model and overwrote it, it might just not exist anymore. So undo, redo only works in the CAD workspace. Filtering, that's both these tools, basically selection tools for us. Enable or disable direct modeling. There's a direct modeling function inside hyperMILL. We can double click a surface and make it bigger. If you don't want that happening by accident, you can disable, and when you double click, you're just going to get manipulation handles for the entire model. The clipping plane and visibility, as I mentioned before, that's stuff that I added. We will go over adding buttons to hyperMILL. Those ones don't actually, I guess this bar doesn't revert to defaults even when you reset your defaults. So that was a brief introduction to hyperMILL. We covered a lot of stuff there. I will try to add some tags in this video. It won't happen right away, but down the road we'll add some tags so you can quickly jump through the video. Excuse me, but that covers kind of the toolbars, what I think is going to be important to us to get going, and what the interface looks like, so we can get started on actually doing some modeling and generate some toolpaths. All right, until next time.